lesson 4-7. Now some of you said yesterday when you were working with the exponent rules with the product and quotient, what happens for negative exponents? You wrote on your phone. So here's the deal with the negative exponent. The negative exponent for any integer n, where any number where a is not 0, remember we can't take 0 to a power, a to that negative n is always going to be equal to 1 over that. So what that negative exponent is doing, it's kind of telling us negative, to make it not negative, but the reciprocal. So the key thing you want to think about for this is that this is just like your reciprocal. So if I have 4 to the negative 5, I'm going to rewrite that as 1 over, and now it becomes 4 to the 5th. So what it means is, also I want you to add to your notes, is what if you have something like 1 over 7 to the negative 2? Again, here it's going to mean reciprocal. If the negative 2 is in our denominator, we're going to have problems with no negative exponents. By moving it, notice this was in the numerator, it moved to the denominator, it made it a positive exponent. Now we're going to move from our denominator to the numerator. It will be 7 to the 2nd, all over 1. So the beauty of that negative is that when you move it to the other spot, it becomes positive. So what I'd like you to do is, in your notes, you should have had that filled in for 4-7 for negative exponents. You are now going to go right below and put example 1. Now what I need you to write for example 1 is just this part. You're going to put 1 over 1 billion. Now it says the speed of a computer chip is measured in nanoseconds. Write this as a power of 10. So the first thing we want to look at is how many zeros do we have. And in this case, we actually have 3, 6, 9 zeros. So on your paper, your directions are write as a power of 10. So please make sure with this, you put write as a power of 10. So first thing, we're going to put this as 1 over. We count the number of zeros, 3, 6, 9, 10 to the 9th. But since I want it as a power of 10, since this is the 9th power, what I now have to do is I'm going to move my denominator to the numerator, and my answer will be 10 to the negative 9. And all that's telling us is not that it's going to be a negative number, but that it's the reciprocal of that. So it says 1 nanosecond is actually going to be 10 to the negative 9 seconds. Here we're going to use our rules from yesterday that we worked with 4-6. 6 to the 4th times 6 to the negative 7. What did our rules say when we multiply? We add the exponents. So we have 4 plus a negative 7. 4 plus negative 7 is going to give us 6 to the negative 3. As you're writing this down, I want you to have this work. Make sure you can tell those are exponents. So now I'm going to rewrite it, and if I'm rewriting this, my answer is going to be 1 over 6 to the 3rd as a power. Now, what you're going to notice is that you can leave it as 1 over 6 to the 3rd if it asks you to give your answer as a power. But if you're asked to evaluate that, that means get it down to without a power. We would now not take 6 times 3 and get 18, but 6 times 6 times 6, and our solution would be 1 over 216. Again, if you need to pause this and go back over and take a look at it, please do so. The next table, or next one you're filling in, is for any number a not equaling 0, a to the 0 always equals 1. And you can try this with many numbers on your calculator. All it's saying is that anytime I have something to the 0 power, it equals 1. I'm going to show you that a little later in the video that kind of illustrates why that is, so that you'll be able to see that. But right now, this is a key thing to memorize. So if I ask you in class 7 to the 0, you tell me 1. 20 to the 0, you tell me 1. 1/2 to the 0, 1. Anything to the 0 power is 1. So now example 3, and again you could probably do this on the inside cover of your notes. You're going to write down, simplify. Use only positive exponents. So if we are only using our positive exponents, we're going to start with 9 times x to the 0. We want to separate those out. So you actually want to write 9 times x to the 0. What do we know x to the 0 is? It's equal to 1. Negative 9 times 1 gives us negative 9. Put down example B. Now the key thing it says is an expression such as negative 9x to the 0 or negative 3a to the negative 4. The exponent is applied only to the variable, not to the coefficient. So it's nice to separate these out because the 3 is not raised to the negative 4 power. So you're going to rewrite this as negative 3 times, and now you're going to put a to the negative 4. As we look at that, we can't have negative exponents. So the negative exponents, to change that, we are going to put negative 3 over 1 times 1 over a to the 4th. Now we're going to multiply our numerator and denominator. We cannot simplify, so negative 3 times 1 gives us a final answer of negative 3 divided by a to the 4th. Again, if you need to pause these and look at them, go back and look at these when we do the guided practice to help you out, to show your work. I'm going to do a few of the guided practice and you'll do the rest. As you look at question C, it says 10 times 10 to the negative 3 divided by, or t to the negative 3 divided by t to the second. How are we going to write that? We're going to put 10 times t to the negative 3 divided by t to the second. Now remember, when we have division, we're going to put this as 10 times t, and now we're going to subtract our exponent. So we're going to put negative 3 minus 2. Make sure those are exponents. So negative 3 minus 2, some of you might want to rewrite that as plus a negative 2, always changing our subtraction. That gives us 10 and t to the negative 5. Well, our rule said no negative exponents, so we're going to rewrite this as 10 over 1 times 1 over t to the 5th. What is my final answer? 10 over t to the 5th power. Again, if you need to pause this and take some time or go back over this to think about all these rules, do so. Here are the guided practice that I would like in your notes. Number 1, a to the 0. 8 to the 0, what is it equal to? Number 2, negative 2 to the negative 6. I would like your answer first as a power. No negative exponents. And then tell me what it's equal to with 1 over and tell me that that number will be. In number 3, you want to apply the rule. Remember, this is 7 to the first times 7 to the negative 2. So first show me your rule. What does it mean when we multiply? What should we be doing with our exponents? Then you're going to change it if you have negative ones. Now I know you can't see all of number 4 to copy down. Oops, I moved a little too far. But number 4 is 12 to the negative 9 times 12 to the 9. And again, similar to number 3, your first step is to tell me 12 and what are you doing with those exponents? Show me that. Then tell me 12 to what power. Again, down here, my hint would be as you do 5 through 8, simplify it. Rewrite it as 5 times y to the negative 3. Here, we're going to use our exponent rule. Now, what am I talking about the exponent rule? This is 6 and 3 and 4 and 7 and 8 all have those. So in number 3, I have 1 and negative 2. What I wanted to see on your paper would be that you show me that you're taking 1, the rule is, plus negative 2. Because they're being multiplied, we're adding them. That leaves us with 7 to the negative 1 power. What is 7 to the negative 1? That means 1 over 7 to the first, or just 1/7 for an answer. You're going to try number 4 now. Try number 5. Remember, the 5 is not to a power, so we're going to leave that be as 5 over 1. Here, like in number 3, show me what you did first with your exponents. Number 8, my hint would be, rewrite the problem as 8 over 1 times p to the second over p to the negative 4. Show me your rule with division from 4, 6. Here, yes, I would put the two numbers over each other. You know how to simplify fractions, do that. And then put the x's over each other. Remember, that's x to the first and x to the 10th. Again, only positive exponents. So when you come into class tomorrow, I should see these. We will look at these to go over. If you need to pause the video, I'm not going to have you do any more examples, but I want you to see this next part. This next part is kind of talking about why do we have those negative exponents and why is anything to the 0 power equal to 1. If you think of 2 to the 5th, it really means 1 times 5 twos, which gives us 32. 2 to the 4th means 1 times 4 twos, which is 16. What is 2 to the 3rd? It's 1 times 2, 2, 2, times 3 of them gives us 8. So 2 to the 2nd we can think of as 1 times 2 times 2, which gives us 4. 2 to the 1st is 1 times 1 2 only, which gives us 2. And this is going to have 0 2's, but it's 1 times no 2's, which gives us 1. So it says any base raised to the 0 power is always 1. You got to get that in your memory. So if I would look at 4 to the 0, you should tell me 1. How about 1/2 to the 0? That's 1. Anything to the 0 power is 1. Now, another way of thinking about this is how could we simplify a problem if we had it like this? Well, what would 7 to the 0 be? You should have 1. 1 plus 5 would give us 6. I just wanted you to kind of see where that 1 comes from. If I would put down 2 to the negative 1, remember that'd be 1 times 1 over 2 to the 1st. That's how we get 1/2. What is 2 if we wanted to continue our table? To the negative 2. Again, that's going to be 1 times 1 over 2 to the 2nd. And again, if you wanted to write that out a little, you could write that out as 1 over 2 times 2. And you have this 1 out in front. That's how we get 1/4. Now, a lot of people will just, if they put that in their calculator, they're going to get 0.25. I want you to make sure you can show me the rule. And the rule is if I have 2 to the negative 3, that's going to be 1 times 1 over 2 to the 3rd. 2 to the 3rd we noticed was 8. This is its reciprocal, 1/8. So one of the things you notice is we talked about the negative exponent is reciprocal. Look at 2 to the 3rd, it's 8. 2 to the negative 3, 1/8. It does not make it negative. Hopefully this went well for you. See you in class.